to find the area of rectilinear figures, we also want to solve more multi-step problems. The point A has coordinates 1, 4, and the point B has coordinates 5, 6. The perpendicular bisector of AB intersects. Okay, so we make a sketch of this. We have the coordinate A 1, 4, and the other endpoint of the line segment is B 5, 6. The perpendicular bisector of AB means that a second line that divides AB into two halves and has 90 degrees to it. So this point of intersection of the two lines becomes the midpoint. The perpendicular bisector of AB intersects the S-axis at the point C, intersects S-axis at C. So it means that there is a point C on this perpendicular bisector, and we learned that at the S-intercept, the y coordinate is 0. And this perpendicular bisector intersects the y-axis at the point D. It means that there is a point D on this perpendicular bisector. We learned that at the y-intercept, the S coordinate is 0. Find the area of triangle OCD. To determine area of OCD, we need the coordinates of C and of D. So we'll be substituting coordinates D 0, y, coordinate C S, 0 into the equation of the perpendicular bisector. Now that the equation of the perpendicular bisector is not known, we need to find it. So how do we start? To get a gradient of CD, let's find a gradient. First of all, find gradient of AD. Gradient of AB. Gradient of AB. Gradient of AB is change in y 6 minus 4 divide change in x 5 minus 1, and that gives 2 divide 4, which in turn gives 1 divided by 2. So now we can proceed and find gradient of line CD, the perpendicular bisector of AB, minus 1 divided by half, and that gives minus 2. Now we also need a point on the perpendicular bisector to get the gradient, to get the equation. So we find a midpoint of line AB. We add the endpoints, the S coordinates 1 plus 5 divide 2, 4 plus 6 divide 2, and that gives the midpoint to be 3, 5. Next, we find the equation of line CD. I minus y1. Now the y1 is 5. Y minus y1 equals gradient minus 2 multiply s minus s1, and that gives y equals minus 2s plus 6. Adding 5 to both sides, we have the equation of line CD to be this way. Now the point C lies on the line CD. The coordinate C lies on the line y equals minus 2s plus c. So we can substitute this coordinate C into this equation to solve for s. The y coordinate is 0, which implies 2s equals 11, which implies s equals 11 out of 2. It tells us that the coordinate of C is 11 out of 2, 0. Also, we have the coordinate D 0, y on the line. And so we can substitute this coordinate into its equation. Y equals minus 2 multiply the s value 0 plus 11, and that gives y to be 11. It tells us that the coordinate of D is 0, 11. Now we are to find the area of triangle OCD. Okay. Means that find the area of triangle OCD given that O is the origin. The diagram we have drawn tells that this vertical I've indicated with red pen is the y-axis, and the s-axis runs through the point C. So this point of intersection is going to be the origin 0, 0. We should have 0, 0 here so that the coordinate of D can be 0, y, and also the coordinate of C s, 0. Now the s-axis and the y-axis intersect at 90 degrees. So it tells us that distance OD is simply change in the y value here in the coordinate D. 11 minus 0. 11 minus 0, that gives you 11. Distance OD is 11, and distance OC is 11 divided 2. This distance is 11. This distance is 11 divided by 2. That's why I take the change in the s coordinates. 11 divided 2 minus 0 will give you 11 divided 2. So it tells us that the area of triangle OCD is half multiply the base times the height. It's a right angle triangle, so you can use the formula area equals half base times height, where the height and the base meet at 90 degrees. So this gives 121 divided 4, which in turn gives 30.25 square units. This is the area of triangle OCD. Now, there is a second method that we can use to solve for the area of OCD. It's called the shoelace method. How is the shoelace method like? We use this method to find the area of rectilinear figures. Rectilinear figures, we mean a plane figure that is bounded by straight sides. So I have a triangle OBC with coordinates A, B, and C. Area of triangle ABC equals, we move in one sense of direction. You either move clockwise or you move anti-clockwise. So I'm moving from the point A to the point B to the point C, and I'll come back to the point A. area of triangle ABC equals half multiply the absolute of. Now you are coming to write all the s coordinates in the points going clockwise, starting from the point A. The first s coordinate S1, move to the point B, the s coordinate there is S2, move to the point C, the s coordinate there is S3, come back to where you started from, S1. Do same for the y coordinate. Move from the same point, move in the same direction, y1, move to the next coordinate, y2, move to the point C, the y coordinate there is y3, come back to the point you started from, we have y1. Next, we multiply the s1 by y2, s2 by y3, s3 by y1, the downward products. Take the sum of the downward products, s1 y2 plus s2 y3 plus s3 y1. Then you now subtract the sum of the upward products. I call this one the downward product, and let's refer to these ones, the sum of the upward products. So I'm going to subtract these ones. I'm subtracting the sum of the upward product from the first bracket. So y1 s2 plus y2 s3 plus y3 s1. So this is the way we calculate for the area of a rectilinear figure using the shoelace method. So the previous question we solved, we were told that the origin 0, 0 is here. The coordinate D, we had 0, 11. The coordinate C, we had 11 out of 2, 0. So let's use the shoelace method to find the area. Thus, we are doing a second method, method 2. Area of triangle OCD equals half multiply absolute of, go in one sense of direction. I'm starting from C. The s coordinate 11 out of 2, go to coordinate D, the s value is 0, go to the coordinate O, the s value is 0, come back to where it started from, coordinate of s is 11 out of 2. Do same for y, 0, move to D, you have 11 there, move to O, you have 0 there, move to C, you have 0 there. Next, absolute of, take the product of the downward products, take the sum of the downward products. 11 out of 2 multiply 11 gives you 1, 2, 1 divide 2 plus 0 multiply 0, 0 plus 0 multiply 0, you are getting 0. Now minus sum of upward products, 0 multiply 0, 0 plus 11 multiply 0 gives you 0 plus 0 multiply 11 out of 2 gives you 0. So now we get half multiply absolute of 1, 2, 1 divide 2. Now all you should know is that the absolute of a value simply means that the positive of that value. So one other example, absolute of minus 5 is equal to 5. Absolute of positive 5 equals 5. Absolute of a value, it means that we are just interested in the positive value. Just change the sign to positive. Okay, so let's proceed with our solving. Absolute of 1 to 1 divided 2 is 1 to 1 divided 2. So it means the area of the triangle OCD, we get 1 to 1 divided 4, which is equivalent to 30.25 square units. This was the answer we had when we used the formula area equals half base times height to solve. So any of these two methods will give you same results. Okay. We have a next question here. Solution to this question by accurate drawing will not be accepted. The diagram shows a trapezium A, B, C, D with vertices 11, with vertices A, B, C, and D. The side AD is parallel to BC. As you can see in the diagram, there is an arrow on BC, there is arrow on AD, indicating that those two lines are parallel. And the side CD is perpendicular to BC. Yes, we can see 90 degrees. We can see that line BC and line CD meet at 90 degrees in our diagram. Now we have to find the area of trapezium ABCD. Okay. Finding the area, coordinates of D is not given. We need to find coordinates of D, so we use the shoelace method to find the area. How do we find coordinates of D? Let's start making use of the informations we are given. Side AD is parallel to side BC. Okay. The gradient of side AD should be the same as the gradient of side BC, because these two sides AD and BC are parallel. So now gradient of BC, change in y, 7 minus 2 divide change in s, 7 minus 3, and that gives 1 out of 2. Now what else can we do? We can find the equation of line AD. So we solve it simultaneously with equation of line CD. Line AD and line CD intersect at D. So we want to find the equation of these two lines and solve simultaneously. So finding equation of line AD, y minus y1, that's 4, because gradient half, we have found a gradient to be half. Gradient of AD is half. Y minus y1 equals m multiply s minus s1. Now s1 is 11. Okay. Now working this out, y equals half s minus 11 divided 2, adding 4 to both sides, you have the equation of line AD to be y equals half s minus 3 out of 2. Okay, so now finding the equation of line CD, what do we do? We don't know the gradient of CD, so let's find it. Gradient of CD is minus 1 divided by gradient of the other line BC, which is perpendicular to it. We have found the gradient of BC to be equal to half. So gradient of CD is going to be minus 1 divided by half, and that gives 1 multiplied to, so that gives minus 2. So now let's proceed and find the equation of line CD. Y minus y1. Now the y1 is 2 equals gradient minus 2 multiplied s minus s1, and the s1 is minus 3. So this reduces to y equals minus 2s. What we have in the bracket is s plus 3. So minus 2 multiplied 3 gives you minus 6. Adding 2 to both sides, you have your working this way. So now it tells us that equation of line CD is y equals minus 2s minus 4. Now let the equation of line AD be equation 1, equation of line CD be equation 2. So we want to solve these two equations simultaneously so that we get the point of intersection D. So we are finding the point of intersection D. We have gotten equation of line AD to be y equals half s minus 3 out of 2 and we also had the equation of line CD to be y equals minus 2s minus 4. Now solving this simultaneously, we substitute equation 1 into 2. That's wherever you see y, you substitute this for it. So it becomes half s minus 3 out of 2 equals minus 2s minus 4. Multiply through 2 to clear the fraction. You are going to get s minus 3 equals minus 4s minus 8. And that gives s plus 4s minus 8 plus 3. 5s is minus 5. So the value of s is minus 1. We put this equation 3 into equation 2 to solve for the y value. Minus 2 multiplied minus 1 minus 4, and that gives positive 2 minus 4, which in turn gives minus 2. It tells us that the coordinate of the point D is s comma y minus 1 comma minus 2. So we found the coordinates of the point D. Now we can proceed and find the area of the figure using the shoelace method. Found the coordinate of D minus 1 comma minus 2. So area of the figure A, B, C, D, half multiply absolute of. So I want to begin from A, I move to B, I move to C, I move to D, come back to A. So in coordinate A, the S value is 11. So we are moving in this one sense of direction. Move to B, S value is 7. Move to C, S value is minus 3. Move to D, S value is minus 1. Come back to where you started from A, S value is 11. Do same for Y. Starting from A, Y is 4. Move to B, Y is 7. Move to C, Y is 2. Move to D, Y is minus 2. Move to A, come back to where you started from, Y is 4. So now area is equal to half multiplying absolute of. Now you are going to take sum of the downward products. 11 multiplied 7 is 77, plus 7 multiplied 2 give you 14, plus minus 3 multiplied minus 2, that's 6, plus minus 1 multiply 4 gives you minus 4. So we put all this in brackets. Now minus the upward products, sum of the upward products. 4 multiplied 7 gives you 28, plus 7 multiplied minus 3 gives you minus 21, plus 2 multiplied minus 1 gives you minus 2, plus minus 2 multiplied 11 gives you minus 22. Next, this gives half multiply absolute of. The first bracket gives us 93 minus the second bracket gives us minus 17, which in turn gives half multiply absolute of 110. Now absolute of 110 is 110. So this gives us 55 square units. This is the area of the figure A, B, C, D.